This video is going to be on global warming, and I found a website, the EPA, Environmental Protection Agency website, which gives a list of, that's the website's address, which gives a list of key indicators of global warming. So here in this slide you can see I listed some of them: temperature, droughts, temperature highs and lows, ocean ice melt. Okay, all right, let me cover the first part, which is temperature, because I was arguing with some people about they were saying that the temperature has not gone up in the last 20 years. I couldn't believe that. So here, this is U.S. temperature in the lower 48 states. You can see it at the top there, from 1901 to 2011, and you can see on the right of the graph, which is the 2010, the orange is far above average. Average temperature. The orange indicates above average temperature, and the blue is below average temperature. Oh, and this is Earth's surface. These are measurements at Earth's surface. And by the way, we have two measurements. Also, we have the satellite. If you can barely see it, satellite measurements. Two different satellite measurements. The yellow line. It's hard to see, and then a kind of a bluish line, but they're also in corresponding to the surface temperatures taken not from satellite. So we got satellite and non-satellite measurements. Okay, now here's the global worldwide temperature from 1901 to 2011. That's even clearer pattern, as you can see on the left. The blue. The left in temperatures at starting at 1901 are below average, and then they sort of even out to average at 1950, and then they go up again after 1970. The temperature is consistently higher, and yes, and for those temperature aficionados who I'm hearing that there's something about satellite measurements which are far superior than regular ground measurements, and so this includes the yellow line, which it's hard to see, the yellow line, and this bluish beige aqua line. Those are both, and it's on the right side. It doesn't go back to 1901. Those are both satellite measurements, and they show a consistent increase. This slide shows the change in temperature over from 1901 to 2011 by local areas, and red means a large increase in temperature, and then blue means a decrease in temperature over that period. Okay, this next section is going to be on ocean indicators. This first slide here is what they call ocean heat content. Okay, this goes back to 1955 to 2011, and you've got three different organizations measuring it, which corresponds to the three different colored lines. So NOAA is there is the orange line, then the JAM. The blue line, JAMSTEC, that's a Japanese scientist group measuring it. The third line is the green line, which is a CSIRO, that's an Australian group. And as you can see, over this period, which is 1955 to 2011, there's a clear upward trend in heat content. Now, I'm not quite clear exactly what heat content refers to, and what they mean by that in heat stored in the ocean water, but that's one of the key indicators. Now we got another key indicator coming up. This is average global sea surface temperature starting in 1880. I don't know how they got these numbers in 1880, and looks like there's three different estimates in the very early trends in the early time, and then as you get past 1950, you get well, it converges and it looks like you've. And so once again, the trend is upward in a rise in ocean temperature, and actually it sort of maxes out after 2000. Stays quiet. Now the next slide is quite shocking. This is sea level change. I should explain why sea level is a indicator of global warming. The theory goes that as the Earth gets warmer, the ice will melt at the poles and in glaciers and in the northern regions and extreme northern regions, extreme southern regions, and the sea level will rise as the Earth's temperature rises. So here, this is the clearest trend I think we've got, is a consistent rise in sea level from the 1880 measurements up to 2011. And let me explain a little bit more about those measurements. The orange lines are tidal gauge trends, but as you see in the right-hand corner, around 1990, you get a red line, which is for temperature aficionados who are really into this. That's satellite data, which some say satellite data is superior to other kind of data. Now, this is data of sea level change at the coasts, at various specific locations along the coast, and you can see that the sea level has gone up. The red is significant or high change in sea level, and then orange is not so much, and then you get the blue would be the sea level has actually gone down. But you can see in Texas, Louisiana, and then Virginia, New York, New Jersey, significant sea level rise. All along the East Coast and the Southern Coast. So that's another data consideration or key indicator of global warming is sea level. Now this last ocean indicator is the carbon dioxide, dissolved carbon dioxide in the ocean water. And what's happening is, as the carbon dioxide in the air increases, more carbon dioxide is dissolved into the ocean water. And they've got two measurements here. This only goes back to 1983. Their two measurements are, on the left is carbon dioxide carbon dioxide in the water, measured I'm not quite sure how, and I've got Bermuda, Canary Islands, and Hawaii. And then the right column is measuring acidity in the water. As more carbon dioxide is dissolved in the water, the ocean water becomes more acidic. And once again, you've got the same three places: Bermuda, Canary Island, and Hawaii. Now, and the pH level goes down. As the pH level goes down, that means the water is becoming more acidic on the right side. So the trend is going down, meaning the ocean water is becoming more acidic. And on the left column, the trends are going up, which means that there's more carbon dioxide in the ocean water. And then there's all kinds of problems with acidic water and the animal life. Okay, this last indicator is going to be the amount of ice and snow on the planet. And here you can see this is a glacier. This is the McCall Glacier in Alaska. And the top picture is from 1958. You can see there's quite a bit of snowpack or snow and ice. And then the lower picture is from 2003, and you can see a lot of the ice and snow has melted back. These pictures are of the Arctic ice sheet or covering. The top picture is the ice covering at the Arctic in September of 1979, and the bottom picture is the ice covering in September of 2012. So you can see a significant amount of melting at the Arctic region, and of course also this is a problem, means that the ocean will warm up even more since there is less ice reflecting light back, reflecting the light and the heat back out into outer space. This is called the albedo effect. Okay, this slide is the the Arctic ice extent from as measured from 1979 to 2012, and it's by area. And as you can see, the ice extent is shrinking. It's getting smaller, which means the North Pole, the Arctic, is the ice covering is getting smaller over this entire period, practically, except for one or two blips there. And let me see, the last slide is what? Glaciers from 1958, 3 U.S. glaciers from 1958 to 2010, and you can see, what is it, the Wolverine Glacier, Kulakana Glacier, and South Cascade Glacier. I don't know exactly where those are, but in essence, these 3 glaciers are melting and retreating, particularly after 1990. So that's yet another indicator of warming. This just shows the 3 glaciers here in the United States, but I think almost all the glaciers all over the world, in the higher elevations, in the mountains, and in the polar regions, all of these glaciers are melting and retreating, and have been for quite. This last slide, and I'm gonna stop after this. This last slide is the major greenhouse gases and their effect on the global warming, their global warming effect on the atmosphere. And this starts in 1979, going to 2011. And you can see blue is carbon dioxide, which is the most, I don't know what significant greenhouse gas, causing the most warming. Then you've got orange, which is methane, also greenhouse gas. Gray is nitrous oxide, another greenhouse gas. And then you get the CFCs gases. Those are used in air conditioning. Those and refrigeration. They're refrigerants. They have been banned because they cause a hole in the ozone layer in the atmosphere. But I have read that the new refrigerants, the next generation of refrigerants after the CFCs, are also greenhouse gases, and so in air conditioners and refrigerators there's always a problem of these greenhouse gases escaping